What? Oh, wait. Oh, don't do it.
Okay, so we'll continue. So you can have a process where you want to check occurrence of something. And in the end of the day, if it actually occurred, you can check. Now, writing, I also want to highlight something here. Writing this like this, if flag equals to true, is okay, right? It's okay. But in Python, you can still simplify this. I'll change this one to a comment and write how it can be simplified. So you see, you can just say this. Okay? If flag, what this does is, remember, if statement conditions always evaluate to true or false. So if I just say if flag and flag is true, that's it. If flag is false, the next thing that happens is determined. So you don't always need to say equal to true when you're dealing with something that's just like flag that just holds one item. It's not really an expression. Okay? It's just another way of writing it. So whenever somebody is looking at your code, if they are seeing things like this, if flag equal to true, they can already tell that you're kind of like a junior, right? A more senior person who has been using Python would not do it like this. But you see his code looks like this, just if flag. Because he understands that the if statement can evaluate this alone without having to put the condition equal to true. Because if this is true, it's as simple as that. Okay. So let me put down this. This is the example in the book for flag, where you ask the user for an input, like for a number, and then you have your for loop. Let me put his code very well.
Okay. Stay.
This is the example in the book on flag. I just want to bring it to true. You might see flag equal to 0 and flag is equal to 1. Someone is checking it like this. 0 and 1, it's also important to know is the same thing as true and false. Okay. True is actually 1, false is 0. Okay, so you might just see it as a number, 0, and then you take it to 1. So you're just flagging equal to 1 is true. And even if you evaluate it the same way I said, if flag equal to 1, now somebody may just come and do like this. If flag, it also works. Because if flag is 1, it is going to be true. Okay.
So if flag with semicolon can be false.
It can be false. For instance, if this flag is 0, let's say this condition, because here they are trying to look for a condition where your number, whether is it divisible from 2 to num, the range is from 2 to num, right? Maybe you put 5, and then you're checking 5 divided by 2. The first I is 2. So you're basically checking, this kind of condition can be where you're checking, looking for the factors. If the number has factors that can divide it. So if you use 19, for instance, and you're trying to check 19 divided by 1, 19 divided by 2, like that, right? Let's say in the end, I don't think there's any number that can divide 19 apart from 1. It
And
doesn't have any
itself.
factor. it's like a prime number. It's only one and itself that can divide it, right? So in that kind of case, now you see if you're checking using this, if any of the numbers beneath it could divide it, your flag will never become 1. Your flag will be 0. And remember, I said 0 is false. So if you do if flag is 0 and you do if flag, the answer is going to be false. And then what do we say happens when your if condition is false? It jumps to the else block, because this condition here will only run if this is true.
Satisfied.
Okay. And even just to add a little more concept here, sometimes you may want to evaluate this when this is false. You could use not keyword. Okay, if not flag is another way to, maybe my target is to check when flag is not true, when it's false. So what this does is, this condition we evaluate. Anytime this condition finish evaluating, if it's true, not we change it opposite. It will change it to false. If it's false, not to change it to true. So when they say if not flag, that means anytime that flag is not true, do this. You get? It's just like another way of checking for something. But let me remove it. That's not part of the class. It just came to my mind. You can just quickly catch that. You can use not. Okay, but don't mind when it's like this. If it's false, this condition will not hold, and then this condition will hold. Yeah. So I think this for loop is actually trying to check if a number is prime number. So you just put the number, it will divide it by every number before it. If the number sorry, my internet went off. Okay, I'll share my screen again. Yeah, so we're discussing about this flag example now. You're going to divide a number by all the numbers. They are dividing the number by all the numbers before it. And anytime it so happens that any number divides it, flag changes is whatever is holding. So initially flag is false, which is like 0. Then whenever a number can divide that number, which means it's no longer prime, then you just change it to flag is 1, and in the end you check if flag, let me put it the way it was before, equal to 1. Okay, just give me a minute. Sorry for the noise. So the way it was before, so if flag is 1, then you now say the number is not prime because you have been able to divide it by one of the numbers in the loop. Does that make sense? Otherwise, it's a prime
Yes.
number if no number could divide it. So this is how you apply flags. So can we move to the next one?
Yes.
Yeah, certainly.
Now, there might be another issue where you want to find the maximum number or the minimum number in a set of numbers, right? So maybe let's say I'm going to ask the number to the user. Let me say I want the user to enter 5 numbers, and I will print out the maximum number. Okay. So normal, in our usual way, we'll say the user should supply the number. Let me just copy this. Okay. He supplies the first number, and I'll just immediately make it max. The first number the user supplied, I'll just call it the max. And then I need 5 numbers, so I do a for loop for 4 more times. Let me call this J because we've been using I for so long in range 4. Okay. I'll still come and ask the user to give me another number. Remember, I said I want my user to give me 5 numbers. And in the end, I want to know the maximum number. So what I did initially, I asked the user for a number. The first number, I made it the maximum. Then I will go into my loop to ask for 4 more numbers. So each time within the loop, I'll ask the user, enter another number. The user will enter. Just hold on a bit, please. Give me a minute. Okay, so sorry about that break. So within my loop, I ask the person to bring another number, but my aim is to find the maximum number. You can then use this format. If number is greater than max, any number the person is it greater than the max. Remember, we first of all define max with the first number you entered, right? I then keep checking. If the next number is greater than max, then I'll just say max is equal to that number that is greater than it. And it's just similar thing for minimum number finding. So you could just make the first number. It might not be that you're receiving the number from a user input. It might be the number is already in a list, although we have not talked about list. But let me just put this. This is like a list. Let's say it holds numbers like this. So let's say we have, this is a container. We've not talked about this, so don't bother too much about this list. And I want to go through the items in this list and check which one is the biggest. So I'll make the first item to be the maximum, right? And then when I go through the list, as I'm looping, I can use a for loop and loop through. As I'm looping through, I'll be testing, is 2 greater than 1? If 2 is greater than 1, I'll make 2 the biggest. I go to the next number. Is the next number greater than 2? Yes.
7.
Which is 7. Is 7 greater than 2? Yes. 7 now is the maximum. Is 0 greater than 7? No. 7 remains the maximum. Is 49 greater than 7? Yes. The maximum is 49. Is 56 greater than 49? Yes. Which is what I'm describing is just what this condition will be doing. If this next number is greater than the maximum will become that number that is greater. So when you use 56, is 3 greater than 56? No. 56 is the maximum. Is 4 greater than 56? No. 56 is the maximum. So in the end of the analysis, if you print max, I say the maximum is max. So, like the way I just wrote this code, if the user were the one supplying the number and I make my user supply 5 numbers, it will keep, each time you supply a number, it will keep checking if it's greater than the max and make it the max like that. In the end, whatever is the max, in the end is the maximum number. Likewise, minimum. If I want to evaluate this list of numbers, it's the same thing. Is 1 the minimum? At the beginning, the minimum, you just say is 1. Then you say the next number, is it smaller than 1? No, 1 remains minimum. You get to 7, 1 remains minimum. When you get to 0, 0 becomes the minimum. Then you compare 0 and 49, 0 remains the minimum. you compare 56 and 0, and so on. In the end, the minimum will be 0.
0. Okay.
So max and min is just the same concept, right?
Okay. Or the condition will change. If
Exactly, the condition will change. Yes, that's true. So for min, it will be is norm less than min.
Mm.
Yeah. So that's why everything now is just what do you want to achieve. Based on what you want to achieve, you put your code to give you that. So that was a good observation. If you're looking for minimum, you just change the condition here. That's it. So these are like concepts that you should understand as a programmer, because maybe a part of your program can be evaluating to look for the maximum among some numbers. Yeah. And then you check it that way. Although there are still different ways of finding maximum and minimum, so depending on the situation. Like that list I wrote there. In terms of list, there is just a function you can just call on the list, which is max. And to pick out the maximum, you can just min, it will pick up the min, even sum in list. So by the time we get to list, you will then begin to see those operations. But then when you're not dealing with something like a list, and you needed to just, in series of number, find the maximum and minimum, this logic can be important to you. Okay. So let's go to the next one. Comments. I believe now we are familiar with comments in Python, right?
yes.
We've been doing it. This one now is a comment itself because it starts with the hash. Any line with hash, anywhere with hash. Remember, even on a line that is not a comment, in the end, I can come and put a comment. Say, okay, make the first input will be the max. So this kind of comment now, part of the line is not comment. See, after the useful part, I put a comment. Now there's what we say in programming, to have a good code. What makes a code good? Let me remove all of this first. What makes a code good? There are two key things. One, the code has to be readable. Okay. And then two, it has to be scalable. Your code has to be readable and scalable for it to be good. Now, this thing I wrote it in another type of comment, which is what we call the multi-line comment. Okay. Also known as a docstring. The multi-line comment or the docstring. Okay. So whenever you want to have series of lines like this now, instead of you to put hashtag in front of all of them, you can just have a triple quotation mark. I'm using single quotation. Somebody can also use the double quotation. Yeah. Usually in this my IDE, the moment you type quotation 3 times, it automatically brings up the next 3. It's the IDE that is doing it for me, simplifying my work. Right? Then anything in the midst, you can put even a paragraph and all that. That's the second type of comment you have Python. So these two, this one and this one. But now within this comment, I asked a very good question that what makes a good code? I then put one, the code has to be readable. Now, what makes a code readable is good commenting of your code. So whenever you're solving a problem, you make comments, okay, that will make someone understand what you're doing. Because you can solve a problem today, a coding problem, and maybe in a few months' time, you come back to the problem and you look at it. Even you that is the person that solved the problem, when you look at it, you will not
I don't
understand
remember.
what you did.
What?
You start saying, why did I do this? Why did I do that? Now, if you don't comment your code properly, it might even you might spend time recalling what you did. It's not like you totally forget. You might be able to recall it, but you would have wasted time, right? And again, whenever you're coding, you also bear in mind that your code might be used by someone else. And when I say coding, I'm not talking about when we're solving all these exercises. I think in proper working condition now, you're developing an application. It's just like I want to talk about Google search. We are using Google search today. Many people that are probably working in Google on that search machine, they are probably not the people that started it. A lot of the people that started it may have retired, or for some reason they are no longer there. But there are new people there, and you can be recruited tomorrow to be in that team to keep optimizing Google search. When you're employed, you're going to see a code that someone has written before. Now, if the person does not make his code good, if he doesn't comment it well and makes it readable, you will struggle to understand what was done by your predecessor. So for that, making your code readable is very key in programming. And how we make it readable is we use comments, and also we use variable name that has meaning, right? The variable name has meaning. So maybe if you look at this example again, when you see max can even just help you to understand that somebody is trying to do maximum. You get, without someone have to tell you what is this variable. The naming now is giving it meaning. And in addition to that, you can use comments, but you have to also still be careful that you don't over comment your code. Well, with time, we'll get to understand that it's not everything you need to spell out in comment. So sometimes we make the code self-explanatory, and that's by the way your code flows and how you name your variable. Does that make sense?
Yes.
Okay. Then the other one will say scalable code. We will not delve into that for now. We'll leave scalable now. Just for now, comments, we just highlight making your code readable. Stop it. Okay.
Mm.
Does anyone have any question?
Eh, I wanted to find out something for
Okay.
you. I came across a loop
Mm.
that says for underscore in the range of. What does it mean?
Oh, okay. So instead of using J, they put it like this.
Mm. Yes.
Okay, it's possible. Remember, I think in one of the chapters, we talked about there are rules for naming variables. Okay.
Mm.
And what your variable can be made up is number, underscore, and alphabets. So underscore can be used as a variable. It's very possible. Okay, so
Not a
it's
connecting
just this.
words.
Pardon?
No longer for connecting words.
Yeah, so it can be used like earlier on. I use it in making my, for instance, here now I'm trying to do some odd numbers, and I call this some odd. I use underscore there, right? And that's also variable naming. Somebody, once he sees this, he can understand that I'm doing some of odd numbers without even me writing a comment about it, because of the way I named the variable. Using underscore, you can connect words. Okay. And you can actually use underscore to start a variable name. That is why this can happen. Because it can be maybe a variable name of max. You can even have it like this. Max equal to maybe 1 or 0. You can have something like underscore. It's allowed in variable name. But you cannot have number starting a variable name, maybe 2 max. You can't have that. Equal to 1. This one will not work. But you can have the number. If the number is not in the front, the number can be inside, in the middle, or at the back. It works. Okay. You can name your variables with capital letter and small letter, but the general practice, we don't name variables with capital letter. It does not mean if you do it, it will be an error. It's not an error. You can call it max. It's not an error with capital letter. Max equal to 1. It works, but it's not a good practice, right? If someone else sees your code,
Okay.
you look like you don't really know Python or know the
Very
some
well.
principles of coding. Yeah. It's possible to name it max, but with capital letter, but just general good practice, don't name it with capital letter. Name your variables with small letter. You could also have what we call the camel case. For instance, the other one I did before, I named it some odd. Somebody can do it like this. Some odd equal to maybe 2. This one now, maybe instead of using the underscore, you then use this type. It's camel case. Normally, odd number would have been small letter, but you make it a big letter. So anytime you want to, in this kind of variable name in camel case, you want to put the next word, you start with capital letter. So you can even say something like this. Name of is just a short word. Name, somebody can say space like this. Okay, camel case. So once you see it, you'll be able to know that, oh, name and then space. So you have different words, maybe in. So you see this kind of, it's like a sentence namespace in Python, but I made it a variable. And I use this type of approach, it's called camel case, where you'll be having some up and down, but it's giving some meaning to the variable name. Okay?
All right.
Yeah, so that's a good question. Then, any other questions so far? So that's for comments. Like I said, scalable code. We will not talk about that now, but just know in your mind that you can use underscore as a variable if you don't intend any variable letter in code. Okay. Now, when we talk about scalable, what I want you to have in mind is there are efficient coding. So even as you are writing your codes, sometimes you can write a code and it solves the problem, but it wastes time. It's slow. And then you can improve your solution to make it faster. So programmers typically, when they are writing solutions, they think about that performance of their code in terms of how efficient it is in time. So later, we'll talk about scalability, but it's a bit later, right? So that's talking about scalability. Because then lastly, debugging. Simple debugging. In your code, let me just ask it as a question to the class. How can we debug while coding? Because some of you have been solving the problems. I'm sure you've been debugging.
Yeah, we have. I don't know.
How have you been
How
debugging?
for me personally, when I want to debug my code, I use the inbuilt debugging system within the IDE. Like when I have an error in my code, I use the inbuilt debug checker to check the lines where the error is found, and then I use the the error name, or I can say the name error, just like you have on your terminal. It helps me understand what my error is about, what type of error I'm experiencing. So yes, just that. So I can know where and what I can change to make the code go through.
Okay. So which one is the inbuilt debugger?
There's this PyTest. I've not used it so much, but I've only used it once. Well, I really don't like using it. I use the one on the IDE.
I understand. PyTest is a module in Python that is used in testing for quality assurance anyway. But that's well, we can say that's an advanced way to say you're debugging your work. But today we'll just be doing simple debugging, right?
I use Sprint myself anyway.
Okay.
I try to find a variable. If I'm stuck somewhere along, if the code is running and I'm getting error, I can just insert a few print statements in a few places to just
Okay, great.
find out what's.
Great. There's also the last person that spoke. Actually, when you talk about simple debugging, the first thing that should come to your mind is print. The use of print. Okay. Sometimes now, when you get the wrong answer, you want to see what is happening in your code. You can put print, I can inject print statement. For instance, this norm now, something is happening here. I want to see what's happening here in my code. I can just come here and say print norm, right? Then it will print all the norm. I'll be seeing it in the time. I'll run the code. I'll see it in the terminal. Some of you have been doing this. It's a way of debugging. That's the primary way of debugging. You use the print statement in your code to see the variable as the code is running. What is it at that point in time? You can do this. Then you can also use the breakpoint. So when he said the inbuilt debugging system, I thought you were talking about the breakpoint. Although it's not also what we say simple debugging too. Okay. But just for simple debugging, we'll keep it as print. And another way to do it is you go into your Python shell where you can say something like, this is the Python shell. So maybe there is a particular arithmetic that is in your code and you're not sure if it's working well. You can enter the Python shell and try it out directly and see what it will give you, right? Are we together?
Didn't get the last statement.
I say you can come into this. Let's try something. Let's say print. Or in the okay, I was saying that sometimes you may want to check something happening in your code. You can open up your Python shell like this and try it out to see what it means. So remember, I told you before that 0 is false. So maybe I just want to check that and see how I can do it here. So I just, in the shell, I say print. I hope this works. Bool of 0. What will bool of 0 be? False, right? Right there in the Python shell, I just ask to print bool is for boolean of 0. What does boolean of 0 mean? False. If I bring it up again and change it to boolean of 1, what is bool of 1? See, it is true. So this is like a quick check. I can just execute. I'm not running my code, but I'm not sure. Maybe, as I said, 0 is false and 1 is true. I just want to check it to confirm. I could jump into Python shell by just typing Python, hit enter, and I'll just put the expression and quickly see. So it helps in debugging, just checking some things quickly. So any question?
What about the breakpoint?
That one is not part of the simple debugging, but usually what that does is pauses the code So if I insert a breakpoint maybe at this point, when the code runs, when it gets to the breakpoint to come on the terminal, right? And then I can begin to check for, if I put a breakpoint maybe here, instead of putting print in the terminal here, I can begin to check what norm is at that point. I can enter into my code as it's running and begin to check things. But just leave that one for now. That is a little bit more advanced and simple debugging.
Okay.
So you just like pausing your code and entering inside to do something, to check, like carry out an operation while the code is moving, just to check what things are. Okay. Because when you're writing some codes, all these print, especially print, it's the simplest. You use it to see things, know what things are. You understand?
Yes.
Any other question?
Outside of coursework.
Outside of coursework?
Yes.
Sure. But then the topics are over now at simple debugging. So these are what before you go to something else, these are what this chapter is trying to bring to us, right? What I just tried to explain, and then you look at some examples. And I think I saw something else that is key. Looking at the book, sorry, in the next 1 minute, let's look at these two examples. They highlighted something here, very important. The flow of your code. Where you put things in your code matter. Okay. In this first code, the person put round int, random equals round it 1 and 5 before the for loop, and started running the for loop, hello times random. And if this generated number 2, you will just have two hellos, it doesn't change. It's different from when someone puts it inside the for loop, because when it's inside the for loop, this will run every time the for loop is running, right? And generate a new number. And then you can see you have different lengths. So what I'm bringing from here to us is where you place something in your code matters. So if you watch even all our examples.
Yes, I think that's
So like you see where we put our count, we don't just put count.